Good morning, children. This is class 11th physics, chapter number 11, thermal properties of matter. So, children, you might have noticed that your sunny afternoon, they are quite hot as compared to the windy nights, right? Why? What is the difference? So, children, basically the difference is in the temperature. The temperature is very high in the sunny afternoon as compared to the night, right? So in short, we can say that when the temperature is more, the heat is more, and when the temperature is less, the heat is less, right? So that is what here, the hot sunny day, the temperature will be more, and so the heat is more. And if you compare it to the ice water, the ice water is heat is less, so it is cold, right? As its temperature is less. So let's see how we can define temperature. So temperature is the measure of degree of hotness or coldness of a body, right? How much hot is the body or how much cold is the body. So children, temperature is a relative term. It is not an absolute term, as we had done in class 9, that motion is a relative term, right? For example, if earth on earth, this is your earth, if you are sitting on your chair and you are studying, you will say that, ma'am, I am at rest. But if an astronaut is seeing you from the moon, he will say, no, you are in motion. So motion is a relative term. Similarly, children, your temperature is not an absolute quantity. It is also a relative term. So here I am having an example of a cup of hot soup and ice cream scoop, right? So you will say that the temperature of the soup is, or the soup is hotter as compared to the ice cream, right children? If I put a volcanic eruption over here, so uska temperature to soup se bhi zyada hoga, right? Then you will say that the volcano or the lava is hotter than the soup, right? So how we will define temperature? It is the degree of hotness or coldness of a body. Now let's talk about heat. So then basically what is heat? We know heat energy. So heat is a form of energy, right? Which can be transferred from one substance to another, from one system to another. Why? Because of the difference in the temperature. Suppose you go to your friend's house and he serves you a cup of hot coffee. It's quite winter, right, children? So suppose you start your gossiping and you just forget the cup of coffee. Then after a while, if you just pick the coffee, you will see that the coffee becomes cold. Where has the heat gone from the coffee? The heat has gone, or the heat has been transferred to the surrounding of the coffee, right? Because the coffee was hot and the surrounding temperature was less. There was difference in the temperature. So heat got transferred. The heat of the coffee got transferred to the surrounding. And so after some time, you see the coffee becomes cold, right? Now, as heat is energy, we know the heat in energy unit is joule, right? There are other units of energy as well, that is calorie, and the greater unit is kilocalorie. And if you want the relation between joule and calorie, so 1 joule is 4.18, sorry, 1 calorie is 4.18 joule. And 1 kilocalorie, kilo is 1000, so that is 1000 calories. Now, children, the unit of temperature, we know degree centigrade, we know Kelvin, we know Fahrenheit. But the SI unit of temperature is Kelvin. We had done this in chapter number 2, units and measurements. The SI unit of temperature is Kelvin, which is denoted by the symbol K. No degree you are going to put here. Degree will be put in only Fahrenheit and Kelvin, right, beta? Chalo. Now let's see how we are going to measure temperature. So we know thermometer is a device which is used to measure temperature, right? Inside thermometer, the liquids like mercury and alcohol are used, right, in liquid in glass thermometer. Now, suppose children you want to construct a thermometer. So for constructing a thermometer, you require lower fixed point and upper fixed point. After fixing the lower fixed point, LPF and UPF. After you fix them, you can divide this much distance into equal number of divisions and then you can mark them, right? So to construct a thermometer, you require two fixed points which are known as reference points. So these fixed points are, the lower fixed point is the ice point, means the temperature at which the water freezes, and the upper fixed point is the steam point or the boiling point, the temperature at which the water boils. These all are under fixed pressure, means you are not changing, it is under standard pressure, right? So suppose we are talking about Fahrenheit scale. Beta तो Fahrenheit scale के लिए the ice point is 32 degree Fahrenheit and the steam point is 212 degree Fahrenheit. So here the lower point is 32 degree Fahrenheit, upper fixed point is 212 degree Fahrenheit. Right, and so it is divided into 180 equal divisions. 212 minus 32 karoge, then you will see it is 180. So you will divide them. You will divide the whole scale into 180 equal lines, and so that will be your Fahrenheit temperature thermometer. And you know, in Celsius, in degree Celsius, you know that the ice point is 0 degree centigrade and the boiling point of water or the steam point is 100 degree centigrade. So 0 is the lower fixed point, 100 is the upper fixed point. So you can divide it into 100 equal intervals between these two reference points. Now children, if you want to draw a graph of temperature in Fahrenheit versus temperature in Celsius. So children, we know that in Fahrenheit, the lower fixed point is 22 degree, right? The lower fixed point, sorry, is 32 degree, right? And the upper fixed point is 212 degree, right? So 32 or ye dekho 212 on Fahrenheit. But on degree centigrade, it is 0 degree and 100 degree. So when it is 0 degree centigrade for Fahrenheit, it is 32. And at 100 degree centigrade, the Fahrenheit scale is 212 degree Fahrenheit. So this is your graph of temperature at Fahrenheit versus temperature at Celsius scale. Right, children? So if you want to, the equation, if you find from this, then it will be temperature minus lower fixed point upon the total number of divisions, equal to temperature at lower fixed point upon total divisions. So here if you want to find out about Fahrenheit, we'll write F, here we'll write centigrade, here we'll write Fahrenheit, here centigrade. So temperature at Fahrenheit, so it is TF, minus lower fixed point of Fahrenheit. Lower fixed point of Fahrenheit is 32. Upon total number of divisions on Fahrenheit, 180, equal to temperature in Celsius minus lower fixed point of Celsius is 0 degree. Upon total divisions to 100 है ना बेटा? So by using this equation, you can convert a Fahrenheit temperature into Celsius temperature. अगर आपको Fahrenheit की value दी है, तो you will substitute PF here and you can find the value of TC. And if temperature in Celsius is given to you, that value you put here and you will get the temperature in Fahrenheit, right? So this is the equation which relates temperature in Fahrenheit and temperature in Kelvin. Using the same concept, we can put the equation for the third unit, that is Kelvin as well. Now, this is very important, children. Ideal gas equation and absolute temperature. So, children, if you use gas in a thermometer, so at low pressure, low temperature, when the temperature is very, very low, all the gases, they behave the same way. All the gases, they will have the same expansion. जितना गैस ए एक्सपैंड करेगी उतना ही गैस बी एक्सपैंड करेगी फॉर अबाउट सपोज 2 डिग्री सेंटीग्रेड टेम्परेचर इंक्रीज होगा तो दोनों में जो एक्सपेंशन होगा दैट विल बी सेम at low temperature. So children, if you want to describe the behavior of an ideal student, then you will say we should check the punctuality, we should check his regularity, we should check his sincerity. So similarly, if you want to describe the behavior of a gas, then you should talk about the quantity, the pressure of the gas, the volume of the gas, and the temperature of the gas. So these are the quantities which will help us to describe the behavior of gas. Right, children? Now, here I am having a simple setup. In this setup, this is a cylinder, and in the cylinder, we have fixed a piston. So this is just like your syringe. Injection, hai na? Injection is an example of simple piston. So this is like that. So we can pull this piston and we can push the piston. We can apply pressure on the piston. Right, children? Now, inside the piston, inside the cylinder, we are having a gas filled over here. Right? Now, suppose the temperature of the gas is 32 degree Celsius. Suppose the temperature of the gas is 32 degree Celsius. And after that, neither you are allowing the temperature to flow out of the system, out of the cylinder, nor you are applying, nor you are supplying any temperature or any heat to the system. So the temperature of the system will remain constant, that is at 32 degrees centigrade. So it's much clear. Now what we are doing? We have fixed the temperature. Now children, if I pressurize the पिस्टन, अगर हम पिस्टन को यहाँ से फोर्स लगा के पिस्टन को पुश करते हैं, then children you will see that the position of the piston will be somewhat like this. Piston थोड़ा सा नीचे आ जाएगा and this will be the position of the piston. So as you are increasing the pressure, आपने pressurize किया उसको, right? So as you are increasing the pressure, the volume has become less. वो जो गैस है, वो जो पहले यहाँ पे थी ग्रीन वाली, now वो गैस यहाँ पे आ गई, बहुत सारी गैस molecules, because we have moved the piston down, right? So on increasing the volume, on increasing the pressure, the volume has become less. The volume has become less, right? Pressure increase किया, volume कम हो गया, उतनी ही gas molecules है वो कम volume में आ गए अब, so the volume has decreased. So you can see that the pressure and volume, they are inversely proportional to each other. If you remove the proportionality sign and if you put a constant here, then it will be P equals to constant into volume. So can I take volume on the other side? So the volume can be moved over here. The pressure upon volume is equals to constant. Sorry, pressure into volume equals to constant because volume to division में है ना बेटा. Volume is in division. So PV equals to constant. Right? This equation is known as your Boyle's law. So according to Boyle's law, if the temperature of the gas is kept constant, then the product of or PV equals to constant. This is your Boyle's law. Right, children? Now, let's study the next law, that is the Charles law. This all you have done in your chemistry. Next is the Charles law. So for Charles law, we are going to keep, children, the pressure constant. The pressure will remain constant. Now what you're doing, you are fixing the piston. Now you are not moving the piston. Okay, the piston is fixed. So as the piston is fixed, these are your gases, molecules. Now what you're doing? Now you are going to change the temperature. So suppose you put a burner over here and you apply heat and then the temperature will increase. So with increase in the temperature, children, just a minute. So as the temperature increases, here you will see that the volume will also increase. So volume increases, temperature also increases. So volume and temperature, they are directly proportional to each other. And if we remove the proportionality sign here, we are going to have a constant and T, right? So T we will bring to the other side. So V by T equals to constant. So the V by T equals to constant is your Charles law. Okay, beta. So from these two laws, we will get that PV by T is also a constant, right? So PV by T is a constant and that constant has been named as R. PV by T is a constant, that is R. Here R is the universal gas constant and its value is 8.31 joule per molecule per degree Kelvin, right? So here this PV equals to RT is applicable for the gases at low temperature. It is an ideal gas equation. Suppose we are having mu number of molecules. अगर gas में number of molecules mu है, so our ideal gas equation will be converted to PV equals to RT. यहाँ पे mu आ जाएगा. That is PV equals to mu RT.